Section 4.2, Angle Relationships in Triangles. What we're looking at in this section today is some really cool properties about the angles within triangles and also some angles that are outside of triangles and how they all kind of play off of each other. The first thing we're going to look at is this very important theorem, and you know this fact before you know this theorem, but all the angles in a triangle add up to 180 degrees. Now, you probably already know that because you've heard it before, but let's kind of dive into why that is the case. All right? So I'm going to use this diagram right here to kind of start, and here's one thing I'm going to do that you can do in proofs is because you've studied Euclid's geometry enough where you can start utilizing it to create a situation that you want. So you know that lines exist in Euclidean geometry, and you know that a line can go through a point in Euclidean geometry. So what we're going to do is we're going to take this triangle ABC and we're going to add in what's called an auxiliary line. All right, a line that's going to benefit our proof. And you can add that because of the line postulate. Lines exist, okay? So let's get our two columns going here. So we have triangle ABC with L, and here's the next thing I'm going to do. This is because of Euclid's parallel postulate also. I'm going to say that line L is parallel to line segment AC. So L is parallel to line segment AC. So the line postulate, you can add an auxiliary line into a diagram. And then Euclid's parallel postulate, you can make that line parallel because it's going through a point that is not on AC. So we know that line L is unique as well. And all of that is our given information. So if you ever want to add other geometric objects into a proof, you can do that. Just cite the proper postulate. The next thing I'm going to do is I'm going to come up here, and I got angle A, and that's unambiguous. You know what angle A is. It has a vertex all by itself. Same with angle C. But up here, the vertex B is kind of acting as a vertex for a couple of different angles. So I'm going to go up here, and I'm going to go 1, 2, 3. Okay? So I want to get measure of angle A plus measure of angle B plus measure of angle C equal to 180 degrees. So what I need to do is I need to get 180 degrees into this proof somehow. I need to get an equation with 180 degrees into this proof. How I can do that is I can look at 1, 2, and 3. 1, 2, and 3 are all adjacent to each other, and they form line L. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. That is by the linear pair theorem. 1, 2, and 3 all form that straight angle. So now I have my 180. Now 2 is representing the measure of angle B in the theorem. I need to get A into it, and I need to get C into it. So I need to replace 1 and 3. Well, because L is parallel to line segment AC, we have some alternate interior angles. So the measure of angle A equals the measure of angle 1. Also, the measure of angle C equals the measure of angle 3 by the alternate interior angles theorem. So put a little arc, put a little arc, put a little double arc, and a double arc. So now, let's do some substitution. Let's get the measure of angle A into the 180 degree equation. Let's get the measure of angle C into the 180 degree equation. So take A and replace 1 with it. So measure of angle A plus the measure of angle 2 plus the measure of angle, take C, Replace the measure of angle 3 with measure of angle C. And that is by substitution. Whenever you're replacing something, you are substituting. And we have our proof of the triangle sum theorem. Remember, theorems can be proven true. So any theorem that you see in this course, there is a proof that supports it. So, the three angles in a triangle add up to 180 degrees. You probably already knew that, but now you know why that is the case, which I think is very important to understand. The why behind things, getting that fundamental understanding and knowledge so you know where the argument is coming from. Now, theorems act as shortcuts, okay? Like the fact that all the angles add up to 180, that theorem that we just proved, we can now just say triangle sum theorem rather than those 4 steps. So they're shortcuts. Theorems allow you to skip over a bunch of definitions, postulates, and properties. Well, corollaries are like the expressway, okay? Corollaries are shortcuts to theorems. A corollary happens when a theorem gets used over and over and over again, okay? So when a theorem is used to prove something new, that's called a corollary. So the triangle sum theorem is used to get these 2 results. The acute angles of a right triangle are complementary, which makes sense. The right angle is 90 degrees. The other 2 then must add up to 90 degrees because they all have to add up to 180. In an equiangular triangle, we know equiangular triangles have 3 congruent acute angles. Well, because they all have to add up to 180, it makes sense that each one is 60 degrees. So that's all about the angles inside a triangle. Now let's talk about some of the angles that are outside of a triangle. Angle 4 is what we call an exterior angle. So it is outside of the triangle. An exterior angle is formed, oops, I got that backwards. An interior angle, my mistake. An interior angle is formed by 2 sides of a triangle, where the 2 sides meet, right there, that vertex, interior angle. An exterior angle is formed by taking one side of a triangle and then extending it out. So then it forms outside of the triangle. One side of the triangle and then an extension of another side. So when you have an exterior angle, you also have what we call remote interior angles. They're interior angles that are not next to the exterior. So angle 3 is directly next to the exterior angle 4. That means the remote interiors, the angles that are away from it on the inside, are angles 1 and 2. And then angle 3 is just an interior angle. Now where this is all leading is to the exterior angle theorem. That the measure of an exterior angle, angle 4, is equal to the sum of the remote interiors. All right? So we know that all the angles in a triangle add up to 180 degrees. We now also know that an exterior is equal to the sum of the remote interiors. And because it's a theorem, that can be proven. So we are going to go ahead and look at the proof of that theorem. So we have this information here, this diagram. Let's go ahead and call this triangle ABC. So, and you know what? I'm just not going to sleep well tonight if I don't fix that triangle symbol. That just looks like a pile of hot garbage, if you want my opinion. And since you're watching this video, you must care about my opinion, right? Okay, so triangle ABC, that is given. Okay, and now we have all these numbers in here. We have that exterior angle formed. So let's talk about triangles. Okay, what do we know about triangles? Well, we just talked about something up here, that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. So triangle sum theorem. We know that to be true. So look at your end result. So we kind of used our given. Now look at your end result. We want 1 and 2 added up to equal 4. Well, in this equation that we've just introduced, we have 1 and 2 added up. Okay, so we have part of what we are going for. We now need to get the other part. We need to get angle 4 into the mix. Well, look at angle 4. Look at the angles it's relating to, and what can you say about angle 4 and some other angles? If you look here, we have angle 4 adjacent to angle 3, and they form a straight line. That means 3 and 4 are a linear pair. Added up, they equal 180 degrees. That's the linear pair theorem. So now we have 1 and 2 added up in one equation. We have angle 4 in another equation. And here's the real kind of key that unlocks this proof. All of these summations together add up to 180 in both equations. That means that we have something connecting them. Measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals the measure of angle 3 plus the measure of angle 4. Okay? If all of these summations equal to 180, that means all of these summations equal each other. And we can say that is some substitution. So look, we have 1 and 2 on one side, we have 4 on the other side, we have 3 kind of as additional baggage. But 3 is on both sides, and isn't 3 the same on the left side and the right side? So if we can subtract that same amount out, we will have the measure of angle 1 plus the measure of angle 2 equaling the measure of angle 4, and we have our proof of the exterior angle theorem. Very cool stuff happening. I'm sure you'll agree with me on that. So, if we look to the next page, now we kind of want to put all of this knowledge into practice. All right? So example 1 and example 2 deal with theorems and corollaries that you saw on the previous page. Remember, in algebra, we gave you equations to solve. In geometry, you have to write the equations that you're going to solve. But the formulas that you're going to use for those equations come from the theorems and corollaries. So look at example 1. What theorem or corollary on the previous page could help you write an equation? Look at example 2. What theorem or corollary could help you write an equation? And then lastly, we have example 3. And that's going to utilize the third angles theorem. You know, every triangle, no matter what it is, the angles add up to 180 degrees. So if angle M and S are congruent, angle L and R congruent, it logically follows that the third pair of angles will also be congruent, the third angles theorem. So examples 1, 2, and 3, take a look at those, and then check your work with my completed notes online.